Hi everyone, welcome back to my channel. I'm Smita, a student of SVCE from CSE AI department. As a part of civil engineering, I'm going to explain a problem about a centroid of a plane figure. So let us learn what is centroid of a plane figure. It is a point at which all area is assumed to be concentrated. So let's learn problem about this concept. Problem 1, centroid. Determine the position of a centroid for the lamina with a circular cutout as shown in the figure. So now its task is to find the exact location of the centroid of this modified figure. At first we have to locate the x-axis and the y-axis. So as much as possible we have to consider the components. Here there is a maximum 4 components as located. One is rectangle and second one is semicircle and the third is triangle and the fourth is circle. Here there is no rule to take the first component as rectangle, second component as semicircle, third component as triangle, fourth as circle. Which component you want first, that component you can take. Here I taken that first as rectangle, second semicircle, third triangle and fourth as circle. So let us locate centroid of the each component. From for the rectangle, from x-axis we have d by 2, from y-axis we have b by 2 and its base is 120 and its height is 100. For a second figure semicircle, it is located centroid. From x-axis we have r and from y-axis it has 120 plus 4r by 3 pi. 120 plus is because we have taken from x-axis, so 120 plus 4r by 3 pi. For third component triangle, from x-axis we have 100 plus h by 3 and for y-axis we have b by 3. For fourth component circle, we there is no need to worry because the circle is exactly located at the center. So let us solve the problem. At first we have to calculate the area for each component. For rectangle we have area formula, base into depth. Base has 120 and depth is 100. 120 into 100 we will get 12,000. For a triangle, area formula is half into base into height. Half into base we have 120 and height is 60. Half into 120 into 60 we get 3600. And for a semicircle we have pi r square by 2 area formula. So pi into r we have 50. 50 square by 2 we will get 3926.99. And for a circle, area formula is pi r square. For circle we have to take a negative sign because we are minusing the circle from the figure, so we have to take the negative of minus pi 20 whole square. We get a negative 1256.63. And next we have to calculate the centroidal distance. Centroidal distance from x-axis, for the rectangle we have d by 2. D is 100 and 100 by 2 we get 50. And for the triangle centroidal distance from x-axis, we have h by 3 plus 100. Height is 60. 60 by 3 plus 100 we will get 120. And for a semicircle, the centroidal distance from x-axis we have r. R means d by 2. D we have 100. 100 by 2 we will get 50. And for a circle centroidal distance from x-axis we have 2h by 2. 2 into h we have 50. 2 into 50 by 2 we will get 50. And next we have to calculate the moment of area about x-axis, that is ay in millimeter cube. Moment of area equals area into centroidal distance. So area we get 12,000 and centroidal distance we have 50. 12,000 into 50 we will get 66 lakh. And for a triangle we have area 3600 and centroidal distance 120. 3600 into 120 we will get 4,32,000. And for semicircle we have area 3926.99 and centroidal distance 50. Multiplying by both, we will get a 19634.5. And for the circle moment of area from about x-axis, multiplying area into centroidal distance, we will get a negative 62831.5. And for the centroidal, next we have to calculate the centroidal distance from y-axis in millimeter. Centroidal distance from y-axis for rectangle, we have b by 2. B is 120. 120 by 2, we will get a 60. And for a triangle, we have b by 2. B is 120. 120 by 3, we will get a 40. And for a semicircle, we have 4r by 3 pi. 4 plus 120. 4 into r, we have 50. 50 by 4 into 50 by 3 pi plus 120. Total we get 141.22. And for a semicircle, centroidal distance from y-axis, we have 2b by 2. 2 into b is 60. 60 divided by 2, we get 60. And next we have to calculate the moment of area about y-axis. Y-axis in millimeter cube. That moment of area is equals area into centroidal distance from y-axis. So area 12,000 and centroidal distance from y-axis we have 60. 12,000 into 60, we will get 7,20,000. And the next for triangle, we may multiply area into centroidal distance, we will get 1,44,000. And for a semicircle, area 3926.99 into centroidal distance 141.22, will get 554569.52. And for a circle, the moment of area about y-axis, that is ax, we will get minus 75,75397.8. And the total we have to calculate the summation of ai. Summation of ai is 18270.36 in millimeter. Summation of ax, we get 1343171.72 in millimeter cube. Summation of ay we get 116518 millimeter cube. At last we have to calculate the x bar and the y bar. X bar formula, we have summation of ax divided by summation of a. Summation of ax, we have 1343171.72 divided by 18270.36. We get 73.71 in millimeter. It has x bar. And y bar, we have formula summation of ay divided by summation of a. Summation of ay is 11655518 divided by 18270.36. Total we get y bar equals 63.79 in millimeter. And thank you for watching.